Welcome to the full solutions to the practice questions from lesson 8, vector operations. In the first question, we want to determine the values of x and y for the following vector operations. And we're pretty much multiplying one of the vectors by x, one of the vectors by y, subtracting them, and we're going to get a resultant vector of -9, -7, and 5 for the x, y, and z components. First, we know that for the x components, we're going to have 3 times x, and then I'm going to multiply these two. I'm going to have -2y, and that's going to equal to the x component of the resultant vector, which is -9. And for the y components, I am going to multiply the y components here, and that's going to equal to the y component there. So I get -2x minus 3y is equal to -7. I can also write my z components as well. So for my z components, I will have x times 1, -2 times -2y, and that's going to equal to +5. So we have x plus 2y is equal to 5, and that is all coming from the x, y, and z components here. And here we have two unknowns, x and y, and we have three equations. I can use any of the two equations to figure out what the values are and then test it using the third equation. So we're given a little bit extra set of informations here. I'm going to use the first two the second two, the y and z components, and I'm just going to multiply this equation by 2 in order to eliminate x. So my top equation is 2x minus 3y is equal to -7. So let's label that equation 1. And equation 2 is multiplied by 2, so 2 times 2 will give me 2x, and then 2y times 2 is 4y, and 5 times 2 is 10. Once I have these, I'm going to use elimination. I'm going to add everything together. These two cancel out. I get 0, and I get 1y is equal to 3. So that means y is equal to 3. And then I am going to sub y is equal to 3 into one of the equations. It doesn't matter. In this case, I'm gonna go into equation 2, and it's going to be x plus 2 times y. Instead of y, I'm gonna use 3, and that's equal to 5. So x plus 6 is equal to 5, and x is equal to -1. So I have now used equations 1 and 2 to figure everything out, and those are my final answer. But let's check and make sure if I did everything correctly using this equation. So 3 times x, which is -1, that's my left hand side, minus 2 times 3, and let's see what that will give us. So 3 times -1 is -3, minus 2 times 3 is 6, and that gives me -9, which is equal to the right side as well. So this is a confirmation that my solution here is correct. Let's look at the next question. For the second question here, we're trying to determine the vector AB, AC coordinates of point C here, and then a few operations afterwards. So first of all, AB here, so if you look, vector AB is originates here and terminates here. We don't have much information about that. However, we know we can figure out vector A. Let's label this one D. We can figure out vector AD, and since these are all equal, well, the symbol means that these sides are all equal, that means that this is 1/3 of that. Let's use that idea. So let's write here, we have vector AD, which equals to, I'm going to take all the x, y, z components of vector point d, so 10, 10, and 20, and subtract them by all the x, y, and z components of a. So that's 1, -2, and 2. Once I have this, 10 minus 1 is 9. 10 minus -2, that's 10 plus 2, so that's 12. And 20 minus 2 is 18. I know that vector AB is 1/3 of vector AD, and therefore it is equal to 1/3 of 9, 12, and 18. That means I have to multiply 1/3 by 9, 12, and 18. So multiplying by 1 over 3 is same as dividing by 3. So I get 9 over 3 for the first, for my x components, and that's 3. 12 divided by 3 for my y component is 4. And 18 divided by 3 for my z component is 6. And this is vector AB. The second part of the question asks for vector AC, so that originates here and terminates here. That's twice as big as vector AB, so we'll use that concept. So this was A4, so for B, AC is equal to 2 multiplied by vector AB. So that's equal to 2. 3, 4, 6. Those are my components for vector AB. And now I'm going to multiply all the components. 2 times 3 is 6, 2 times 4 is 8, and 2 times 6 is 12. And that's my vector AC. For the next question, we want to determine the coordinates of point C. So I'll write that here. And it's going to have an x component, xc, it's going to have y component, and it's going to have a z component. So to do this one, we know the vector AC, and to find vector C, we need to subtract all the components of the point of C, so it's x component, y component, and z component, by all the x, y, and z components of point A. So point A has x value of 1, y value of -2, and a z value of 2. And we know that this is equal to 6, 8, and 12. This is nice, and now we have an equation for the x component, the y component, and the z components. We'll write them down individually. Xc minus 1 is equal to 6. Yc minus -2 is same as plus 2 is equal to 8. And z minus 2 is equal to 12. For the first one, I'm going to add 1 to both sides to get 7. For the next one, I'm going to subtract 2 from both sides to get 6. And for the last one, I'm going to add 2 to both sides to get 14. And therefore, C will have an x value of 7, a y value of 6, and a z value of 14. And that is my final answer for part C. Okay, for the next question, we're trying to find the magnitude of AC multiplied by a vector AB. So to find the magnitude of AC first, we will have to take the square root of its x component squared. So vector AC, first of all, is this one. Its x component is 6, so it's 6 squared, plus its y component squared, that's 8. And its z component squared, which is 12. And that will give me 36 plus 64 plus 144, which equals to root 244, which can be simplified to root 4 root 61 or 2 root 61. Once I have this, I am trying to find the magnitude of AC times vector AB. So the magnitude of AC, well, that's just 2 root 61. That's just what we found. And vector AB is in this one over here. That's 3, 4, and 6. And all I have to do is multiply everything together. Sometimes you can leave your answer actually in this form, and that's sometimes okay. I'm usually okay with it. But if we want them all multiplied out, we have to multiply the x components, y, or the constant by the x component, y component, and the z component. With the x component, 2 times 3 is 6 root 61. The y component, 4 times 2 is 8 root 61. And the last one, 2 times 6 is 12 root 61. And those would be x, y, and z component for my final answer. Finally, part E is asking us to find the, well, the magnitude of AC multiplied by the magnitude of AB. We already have magnitude of AC, but we do need to find magnitude of AB. So let's do that here. Magnitude of AB is equal to the square root of its x component squared. So that's here, 3 squared, plus its y component squared, plus the z component squared. And that is equal to root 61. Interesting. And so basically AC here is 2 root 61. That's what we had found previously. And magnitude of AB, we just found that to be root 61. So then these two becomes root 61 squared, and root and the square are opposite operations, so I get 2 times 61, and that just equals to 122. And since these are magnitudes, and I don't have a unit, so I'll just write this as units, and I'll write this as units for my final answer as well. And I like to highlight my answer as well. So here we go. I hope that this video was helpful in giving you some idea about how to do some of the questions involving vector operations. Thank you for watching.